Welcome to our special class. We're going to look at two topics under probability. Now, probability is spread wide in the exam paper, and there are certain exam questions under probability that you don't need to think so much. And this is the easiest probability distribution, which is called discrete random variable. Discrete random variable. So using this probability distribution, I'm going to do an example, then I'll ask you to solve this question here. You can see it's carrying about 7 marks. So a probability distribution simply looks like this. It has random variables which are discrete. They're distinctive. They're not decimals in this area. So you can have numbers like 1, 2, 3, and 4. Then the respective probabilities that you have should not add up to what? They should add up to 1. Here we have the following, and maybe an x here. So they ask you find the value of x. What's the value of x? The value of x is simply the missing variable for us to get a 1 here. So what is the value of x here? What is the value of x?
0.2.
0.2, correct. Then you'll be asked to find the mean, the variance, and the standard deviation. To find the mean, we're going to multiply the x times the probability. So let's try to multiply there and see what we're getting. So 1 times 0.5, we get 0.5. 2 times 0.1, what are we getting? 0.2. Then 3 times 0.2, what are we getting? 0.6. 4 times 0.2, we're getting 0.8. So the total is called our mean. So this is the value of x, px. That is called our mean. Can somebody sum up? Our mean is going to be equal to what?
2.1.
So you simply multiplied. So to get our mean, what did you do? 2 point what?
2.1.
2.1.
Yeah.
All right. How do we get the mean or the mean? We simply multiplied 1 times 5, 1 times 0.5, then 2 times 0.1, then 3 times 0.2, and 4 times what? 0.2. The sum total is what we call our mean, which is 2.1. Anyone behind on finding the mean, we get our 3 marks there. Then
Please say that again. Please just say that again.
we're just multiplying column 1 times column 2. This times that, we get that. This times that, we get that. This times that, the total is the mean.
Oh, okay.
Then to find the variance, firstly, we square the values of x. Then you multiply by the probability that we already have there. Then you apply these two, you get x squared px. Right? So we already have the probability here was given as what? We already have the probabilities. We had 0.5 here. We had 0.1. We had 0.2. And we also had 0.2 there. Then when we square this column, what we get? 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. So let's multiply the two columns. We can call this column 3, and this is column 4. Let us multiply these two to get our variance. The total is not called the variance, it's called the summation of x times the px. So 1 times 0.5, 0.5.
Colin, so we are only going to square the value of x,
Yes, yes.
not the probability of x.
No, that's a value of x.
Okay.
0.4, 1.8. Then here what we get? 3.2. So what do we get when we sum up here? Total up, what are you getting? Add this, what are you getting? This is 5.9. So to find the variance, we simply subtract the 5.9 minus the square of the mean. So variance is simply the variance of x. How do you find it? Summation of x squared times the probability of x. You subtract the mean, or xpx to the power 2. So what are we saying in this case? 5.9 minus 2.1. So squared. Minus 2.1 squared. What do we get? 5.9 minus 2.1 squared, get 1.49. That is how we find our variance. Then to get our standard deviation, you simply square root the variance. To get our standard deviation, you square root the variance. So what is the square root of 1.49? Square root of what? 1.49. You get 1.22. Anyone behind? 1.22. Are we together?
I want to tell something. When we on the variance there,
Mhm.
summation of x squared and the value of x minus the mean. So I found 3.8.
So
Then
5.9,
after I and then to find
5.9.
yes,
Did you square this?
5.9 minus
Did you square this? It was 2.1 squared.
oh, okay. So sorry, I missed that one. Supposed to square it. All right, thank you.
Right. So that being said, I want you to try question number 2. Find the mean, find the variance, find the standard deviation. Quickly calculate that. I'll give you 2 minutes. Let us see what somebody found. So the number of bedrooms, these are the discrete variables. 3, 4, 5, 6. And the probability of x are given. So to multiply the two, x px, so here we have 3 times 0.25, what do we get?
0.75.
0.75, then 4 times
2.20.
20, then
4.75.
1.7, then 0.30. When you total up, what do you get? In total up, what do we get? Quickly, what are we getting? We don't have calculators.
So Collins, my numbers are a bit different from yours. For example, number
On the
5,
four,
the value of x5, 5 times the probability 0.15. I'm getting 0.75. There I'm getting 1.75. So my total was, my mean was 4.
This is 0.75, then this part here,
0.3.
0.3. Okay, then the total is what?
I found 4.
3.
on 4 by 0.55, we're supposed to have 2.20. There we have 0.2. So there was supposed to have a 2. Yeah.
The figures you're giving me, but the total gives you what?
4.
Confirm? Did you also get 4? Okay. Then we square here now. And we square these figures here, we get 9.
Yes, it's 4.
Here we get what? 16. Here we get 25. And here we get what? 36. So we multiply this again with the probabilities. 9 times 0.25, what do we get?
2.25.
2.25. 4 times 0.55.
18.8.
Are you sure? Or 16 times 0.
2.2.
Yes, 16.
6.
16 times 0.55. You said you got what, 8.8 here? Then
8.8.
0.5 times 0.15. You get what?
3.75.
Then 36 times 0.05.
0.36.
The total was what?
Eight.
15.6.
15.6. So our variance will be what? 15.6 minus what? 4 squared. I sure it's 15.6. So here the value
36, sorry, 36 times 0.05. It's supposed to be 1.8.
36 times 0.05 is supposed to be 1.8.
That's what I found.
And when you total up, what do you get? Okay. Please always ensure you come with the calculators. We are not just learning here. We need to move together. So oftentimes I may not come with a calculator. I need you to solve after you learn the principle. Okay. So maybe let's neatly rewrite it. So we had the values of x as 3, 4, 5, 6. Values of x are 3, 4, 5, and 6. And we squared them, we got 9, 16, 25, and 36. And the probabilities of x were given as what? Probabilities of x were given as 0.25, 0.55, 0.25, 0.55, and finally, we're given as 0.15 and 0.05. 0.15 and 0.05. The total must always be 1. You apply this column 1 times column 3. Then here is column 2 times column 3. So we multiply 3 times 0.25. We got 0.75. 0.75 to 0.2. Okay. 0.75 to 0.2. Then 5 times 0.15. The px probability of x is already given here. And the values of x are already given there. So 5 times 0.15, we found 0.75. So I found 0.75. Then 6 times 0.05, what are we finding? 0.3. So when we total up, this is what we find as a mean as 0.40. This is what we call the mean or mu. Then value of x, we square this, we multiply by the probability. So 9 times 0.25, we found 2.25. Then what was 16 times 0.55? What did you find? 16 times 0.55. 8.8, then 25 times 0.15, 3.75, and 36 multiplied by 105, we get 1.8. When we add all this, what do we get collectively? We found, what did you find? When you add all that, 2.25 plus 8.8 plus 3.75 plus 1.8. We get 16.6. So when you subtract 16.6 minus the square of that, we get the variance. So variance is 16.6 minus the mean squared. So here we're going to have 16.6 minus 16 is 0.6. That's a variance. The standard deviation is when you square root the variance. 0.6 square root. What do we get? Square root of 0.6 is 0.77. Any questions? So this is how we create the discrete random variable. I hope that is clear. Right. Then we go to another question to do with regression. When you're given x and y to calculate the regression line, 2, 4, 6, 8, 10, 6, 8, 5. So what you do is you multiply and you square each individual. Now to start with, regression is used to measure the relationship between two variables. So you'll be given the values of x and the values of y. So let's compute here the values of xy. 2 times 10, 20. 4 times 6, 24. 6 times 8, 48. And 5 times 8 is 40. Then let's square this. We're going to have 4, we're going to have 16, we're going to have 36, we're going to have 64. And here, we're going to square these values of x. We're going to have 100, we're going to have 36, we're going to have 64, we're going to have 25. So what remains now is to give me the sum totals there. Can we do the sum totals quickly?
The last column, the total is 225.
2.5.
X squared. Sorry, y squared is 225.
Okay. Y squared 225. Thank you. So this is 225. Summation of y squared.
Then x squared, it's 120.
120. Then XY
132.
132. The information of X.
$29.
Information of Y. All right. So we're going to do just 4 things. Number 1, sketch. So you look for the highest figures there. It's 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Our Y is here and our X is there. So 2, 4, 6, 8, 10, 2, 4, 6, 8, and 10. So we got the coordinates. This is 2,8, 2,10. So we put it there. 4,6, 4,6, somewhere there. 6,8, 6 here, and 8 somewhere there. And 8,5, 8 is here, 5 is somewhere there. So as you can see, it is down sloping. Now, quick recap or overview of what regression is all about. Regression mainly gives you a picture of the relationship that exists between 2 variables. The relationships can either be positive, can either be negative, or they can be neutral, no relationship at all. So this is given by the regression equation, which is given by A plus BX. This is when the slope is negative, which is given by A minus BX. The A stands for the intercept, where it's cutting the y-axis. And the B stands for the slope or the gradient. So this is when your R is equal to 0, meaning there's no relationship at all. Now, R stands for the coefficient of correlation. Coefficient of correlation can either tell you that the relationship is negative or positive. So relationships here are R is positive because it's upsloping. Here our R is what? Negative because it's downsloping. Here there's no relationship at all. So our key, what have we said was the A? A was the what? What was our A? A was the y-intercept. B was the slope or the gradient. R was the coefficient of what? Correlation. And R squared was coefficient of determination. Y depends on X, so Y is a dependent variable, and X is an independent variable. So the R tells you coefficient of determination, how much Y depends on X. So relationships can be strong, it's positive there, but strong if the dots are close to each other. Positive, but the dots are close to each other, they're weak. This is negative, but the dots are what? Close to each other, so strong. The strength is really ascertained by the R squared. So when your R squared is greater than 50%, that's not that it's a strong relationship. So these two are strong. If the R squared is less than 50%, It's a weak relationship. So the formulas are only 5. 1, you need to know the regression formula, which is given by y plus bx. Number 2, to find the slope. The slope is given by n, summation of xy, plus summation of x times summation of y over n All right. So at this point, and our A is given by summation of y over n minus the b that we just calculated over n. So this is a very easy topic which only takes you 5 minutes to do. So here we have summation of x 20, summation of y 29. So summation of x 20, summation of y 29. What else did we find? Our n, how many pairs we have? Our n is 4. There are only 4 rows there. Summation of y, xy, and summation of xy is 132, x squared 120, y squared 225. So 132, 120, 225. So 132 summation of x squared 120 summation of y squared 225, and our n was 4. At this point, are we together? Then what remains is just an issue of substituting our values in there. So to find the slope, where there's n, we put 4. For summation of xy, we put 132. Summation of x, we put 20. Summation of y, put 29. Then we go down there. N, still 4. Summation of x squared, 120. Summation of x all squared. These are two different. This is the x here you just squared. 20 to the power 2. So when you substitute, what do we get? When we substitute, we find our b. The b in this case will give you negative 0.65. Then here, to find our a, summation of y, we already have as 29 over our n, which is 4, minus, we just found our b as 0.65. Then our summation of x is 20 over n, n is 4. Okay, so when you compute that, you'll find the a, and if your computation is well done, you'll find your a as 10.5. A is 10.5. And since we have our regression equation there, we just substitute those figures there. Where there's a, we put 10.5. Where there's b, we put negative 0.65. And you leave the x as it is. So this is about 5 marks to find the regression equation. Now this regression equation is also called a prediction equation. So sometimes they'll ask you to predict y when x is 10, for instance. So find y when x is 10. So we already found our y as 10.5 minus 6.5x. We're told what is y when x is 10. So here you put 10 where there's a x. So meaning this will be 10.5 minus 6.5, which will give you a 4. We predicted. Give you a 4. So y is equal to 4. The regression is able to help you predict, for instance, if you're dealing with demand and supply, if you increase your price to 10 kwacha, how many sales are you going to make? Maybe you're going to make 4,000 kwacha. So if you want, you can even sketch this graph if you want. You know how to sketch graphs. For instance, if you have 10 minus 2x, example, you put the letters on one side. This will be y is equal to 2x. When this one goes inside, will be adding. Then there's an invisible one there. So 1 into 10 is 10. There's a 2 there. 2 into 10 is 5. So what this means is on the y, it will cut at 10. And on the x, it will cut at 5. This is how we sketch linear equations in their simplest way. This equation is y is equal to what? 10 minus 2x. I just created that equation. Now suppose we're going to use our own equation here, which the data should be on one side. So this will be y plus 6.5 x is equal to what? 10. So there's an invisible one there. 1 to 10 is 10. Okay. Then this is 10.5. 1 into 10.5 is 10.5. Then 10.5, we divide the 6.5, we get 1.62. So to sketch this, we're going to have on the y 10.5, on the x 1.62. This is how you sketch it. And finally, you'll be asked to find the coefficient of correlation. Coefficient of correlation. Right. The formula for the coefficient of correlation is simply given as follows: summation of xy minus summation of x multiplied by the summation of y, and then divide there, square root two things, the variation in x and the variation in y. The variation in x simply found as follows: summation of x squared minus summation of x to the power 2, this one multiplied by n summation of y squared minus summation of y to the power 2. Okay, remember our n was what? Our n was 4. Okay, and our xy, remember xy was what? 132. Summation of x, remember summation of x was what? 20. Summation of y, remember summation of y was what? 29. Then we put this in brackets. This is now your issue between you and your calculator, but you need to follow that formula. So here we have 4 times, and put these brackets to differentiate them. Summation of what? X squared was 120 minus summation of x to the power 2, so 20 squared. You multiply this by our n is still 4. Summation of y squared was 220 what? 225 minus 29 squared, right? So take your time with the calculator there. When you compute, you find your error will be negative 0.75688 or 89. So if your B is negative, obviously your error is negative. You saw how the curve was downsloping. We even illustrated it there. So our error, which stands for the coefficient of correlation, is negative 0.7568. To interpret this, it means X and Y are what? Negatively related, or X and Y are inversely related. Then when you square that answer, what we get is called our coefficient of determination. Coefficient of determination. Coefficient of determination is always positive. So R squared, that's simply multiplying R times itself. Just square your answer in short. So you get 0.573. So interpreting this, it means 57.3% of Y, or in full, 27.3% of the variation in Y is as a result of the variation in X. That is how you explain this. All right. So my homework will be sent to you, but just in case, based on what we've just learned here today, I want you to find 3, 6, 9, 12. Here, given the probability of X as 0.15, 0.25, 0.1, and 0.4. We asked to find the mean, number 2, the variance, number 3, the standard deviation. Question number 2, we're given the values of X and Y as follows: 2, 4, 6, 8, 10. We have 1, 5, 3, 4, 7. Asked that one plot 2, find Y on X. It just means the regression equation. Number 3, find Y if X is 10. And number 4, find R and R squared and interpret. Please don't embarrass me. As you do it, follow through the video as has been explained. I'll expect the work sent to my inbox. I will mark within good time. So don't send on the group, send the work to this inbox I'll need the work before within 24 hours. Unless there are any questions you can ask now.